And this is 4-3b, and this is just some right triangle trig and some identities, continued identities, trig identities. And so an identity, you may have seen this back when you took algebra, but so these are called the reciprocal identities, reciprocal identities, which we already kind of talked about most of them. Reciprocal identities, and sine of theta is equal to 1 over cosecant theta, right? And conversely, cosecant of theta is equal to 1 over sine theta. And you could use these to figure out sines and cosines of things, and also to solve identity problems. Identity, by the way, is something that is equal on both sides and is true for every value of the variable. So if I plug in 30 degrees in here and 30 degrees in here, those two things are going to be equivalent, right? And so the next reciprocal identity that we talked about is cosine of theta, and that's equal to 1 over what? You guys remember? Secant theta, okay? And conversely, secant of theta is equal to 1 over cosine of theta. And then we have tangent of theta is equal to what? 1 over cotangent of theta. And cotangent of theta is equal to 1 over tan theta. But also, tan theta, a useful identity to know for tan theta as well, tan theta is also equal to, since tangent is y over x, and sine is y and cosine is x, I could write tangent of theta as sine of theta over cosine theta. And I could write cotangent of theta as cosine of theta over sine of theta. And so those are called your reciprocal identities. And these become useful when you're when you're trying to find angles using them, or ratios using them, and B, when you're doing a whole section called trig identities, which is like a trigonometric proof, which I like, but some people, they don't like it so much. Okay, so those are the reciprocal identities. Can I move on to more identities? Okay. If you said that sine of theta is equal to 1 over cosine theta, you know what that would be?
Wrong.
That would be a case of mistaken identity. I made that one up. Okay, so Pythagorean identities are based kind of like that is implied on the Pythagorean theorem. So Pythagorean identities, and these are all based off of the unit circle. And the first one is, and probably the most important one, is that sine squared, but the other two come up a lot too, so you should kind of try to figure them all out. Cosine squared is equal to 1, okay? Because that's like on the unit circle, this is y, this is x, and x squared plus y squared is always equal to the radius of 1. Now, sometimes they switch these things around, because if sine squared plus cosine squared is equal to 1, then you also know that 1 minus sine squared theta is equal to what? Cosine squared theta. And 1 minus cosine squared theta is equal to sine squared theta. Oh, and another confusing thing is that when I write it like this, sine squared theta, cosine, this means this, sine of theta squared plus cosine of theta squared equals 1. So this is just a kind of a shorter notation. It's just a notation used to write this. So this means take the angle. So if I were to take, I showed the other class, but if I were to take like 35 degrees or any angle I want in there, and I take the cosine of that angle, square it, or sine of that angle, square it, then I take the cosine of that angle, square it, and add them together, I'm always going to get 1. If you don't believe it, you could try it on your calculator. Okay? But it works. And but this is just a shorthand. It doesn't mean, so don't do it backwards. Don't take the angle, square it, and then take the sine of it. Okay, so this means take the sine of the angle, then square it, and then add them together. Do you want me to show you that that's true? Yeah? Okay, well, I did it with 37. So just to show you that it works for all angles, I would go, I don't know if you could do, I think you have to put it in whole parentheses like this. So I would go, and I'm in degree mode. I guess it wouldn't matter which mode you're in because it should work for radians as well as degrees. But sine of 35 squared plus cosine of, whoops, I got to put a parentheses around there, plus cosine of 35 close parentheses squared, and I should get that that's equal to 1. See? So it works for any angle that you would plug in there. Okay? Questions about that? Then there's a couple more trig identities that also come out of the unit circle, and I always forget these, but try to remember them because you're younger than me. 1 plus tangent squared theta is equal to secant squared theta. And 1 plus cotangent squared theta, and these can be proven using the unit circle, is equal to cosecant squared, derived very quickly. Okay? So that is another one, and these are sometimes rewritten. If I know that this is true, then I could rewrite this actually as secant squared theta minus tangent squared theta would be equal to what? 1. Okay, good. And likewise, cosecant squared theta minus cotangent squared theta is equal to 1. And I don't really have a very good way of remembering these other than the tangent goes with the secant. There's no co in front of it. And the cotangent goes with the cosecant. There's no, there's co in front of both of those. That's all I could, that's the only thing I could kind of help you remember it. Okay, so then sometimes you'll have problems like, they'll say something like if tangent, so using the trig identities, so they're using identities, identities, and tan of theta equals 3. If tan of theta equals 3, they'll say like find cotangent of theta, and then they might be mean and ask you to find secant of theta and secant of theta. So cotangent of theta should be pretty easy. How do I find cotangent if I know tangent? Well, it's just 1 over tangent. So if tangent of theta is equal to 3, then cotangent of theta is equal to 1 over tangent of theta, right? So that's just equal to 1/3. So a lot of times you'll have a problem like that where you're not supposed to use a calculator. They just want to know what is the tangent, or what is a cotangent. And remember, when you're finding a tangent or a cotangent, you're finding the ratio of the sides of a triangle, right? You're not finding the angle, you're finding the ratio of the sides, so you don't really have to do anything. This one is a little bit trickier because that's where you have to use that Pythagorean identity. So you know that, what did I say, 1 plus tangent squared theta? 1 plus tangent squared theta is equal to cotangent squared theta, right? No. I mean equal to, sorry. Is equal to secant squared theta. Sorry. That's what I meant to say. Okay? And then you just plug in numbers. So tangent is 3, so this means take 1 plus 3 square it, and that's equal to secant squared theta. And then I do the math. I get 10 is equal to secant squared theta. So secant theta is equal to?
10.
Is equal to the square root of 10. Yes? Yeah, and this is just for right triangles. Okay. And so, and what does that mean if I were to draw a picture? Whoa, I don't want to draw that picture. That's the wrong picture. I want to draw the picture of a right triangle. Okay. So, if this is a right triangle, and this is theta over here, and so say I know that tangent of theta is 3 over 1. If I did the Pythagorean theorem, there's another way you could think about this. This side comes out to be root of 10, and secant is the reciprocal of cosine, right? So cosine would be 1 over root of 10, so secant would be just root of 10 over 1. See? Okay, so that's the way that works. Kind of nice the way it all fits together, ain't it? All right, two more things, and then we'll be done. Can I move on to the next page?
Yes.
Move right on to the next page. All right, so show that. So this is called solving or proving an identity. Show that, use identities to show that cosine of theta times secant of theta equals 1. So don't show by plugging in a number like 15 and 15 or something like that. I mean, you could do that, and it would equal 1. Like I could show you, say so I'm just going to, I just want to say, like say I plugged in like 30 degrees, okay, in here. Say I use 30 degrees, 30 degrees. What's the cosine of 30 degrees? Do you guys remember? Unit circle. Root of 3 over 2. What's the secant of 30 degrees? It's 2, what is it?
2 root 3 over.
Is it 2 root?
2 root 3 over.
Is it 2 root 3 over 3?
Yeah.
I don't even know. Okay. Yeah, so look, these cancel out. And this becomes root of 3. That becomes root of 3 times root of 3 is 3 over 3, which is equal to 1. Now, I won't make you do that because but what you want to do with this one is just rewrite this to show that it's true for all values of theta. So how can I rewrite something here to show that this side is equal to 1? How can I rewrite secant of theta? What? 1 over cosine theta. Then what happens with the cosine thetas? They cancel out. And I get that that's equal to 1, right? Now, one thing, when you're working with this process called identities, someone in the last class said, oh, divide both sides by secant of theta, and then you get cosine theta equals 1 over secant theta, and 1 over secant theta is equal to cosine theta. That kind of works, but when you're doing identities, you want to, really what you want to do is leave this side alone. Leave the less complicated side alone, and mess only with one side and try to show that the left side is equal to the right side, or in some cases that the right side is equal to the left side. So here's one that gets a little bit trickier, and then we'll be done. Okay? So say I had secant theta plus tangent theta times, they want you to show that secant theta plus tangent theta times secant theta minus tangent theta is equal to 1. Show that this is true. So what do you think I do with the problem that looks like this? FOIL, right? So it's just like terms, and you're gonna FOIL it. It's just like you would if these were two binomials. So secant theta times secant theta gives you secant squared theta. That's the two first. Two outer terms out here give you minus secant theta tan theta. The two inner terms give you what? Plus secant theta, tan theta. What's the two last terms give you? Tan minus tan squared theta, right? Got it? So notice I'm not messing with this or dividing by anything. What could go away? These two terms cancel each other out, right? So you get secant squared theta minus tangent squared theta. And you want to know, is that equal to 1? Well, I guess since I just told you that you could rewrite that identity as that, I guess that's okay. But probably what they want you to do in this case is use the identity that 1 plus tan squared theta equals secant squared theta, all right? And take that and plug this in up here, okay? So now I'm going to substitute that in for that. So I'm using this Pythagorean identity right here to simplify this. And then I get 1 plus tan squared theta minus tan squared theta equals 1. And then what happens? Equals 1? Does it equal 1? And these go away, right? Because 1, and you get 1 equals 1, and you go, okay. Okay? So they're kind of like trigonometric proofs. Yeah, and we have a whole section on that coming up that they get not too much more complicated than that, but they can get pretty, there's some tricky ones where you have to use all kinds of, there's other identity formulas that you have to use and stuff like that. But they're kind of fun because they're kind of like solving puzzles. The other thing with these identities, as long as you go from point A to point B, you prove what you're trying to show. There can be more than one way to prove an identity, right? Like I could have said instead use the fact that I could have said 1 plus tan squared theta is equal to secant squared theta. I could have pulled it. No, I didn't want to do that. Yeah, I could have. Anyway, you'll see there's more than one way to solve an identity as you go. Okay, so that's it. Your homework is page, ready? Page 280. Page 280, same page it was up there earlier. 37 through 72, every third. 74, 75, 78, 79, and 84 through 176. No, 84 through 86. And that's all.